This video is going over question 2 from the 2016 Level 3 Mechanics exam, and this question is focused on rotational motion, sort of mainly on rotational kinetic energy. So we're told that a solid cylinder and a hollow cylinder of the same shape and mass are rolled down a slope. The first question asks us to state the energy changes that take place as the cylinders roll down the slope. So we're assuming that there's negligible heat and sound produced. So in this case we have gravitational potential energy is converted to translational kinetic energy and rotational kinetic energy. Okay, and I'm guessing from the state thing here that this is probably an achieved question. The hollow cylinder has a radius of 0.058 meters. It rolls down the slope and reaches a speed of 0.250 meters per second, so that's v. The rotational inertia of the hollow cylinder is 0.140 kilogram meters squared, that's I. Calculate the rotational kinetic energy of the hollow cylinder at the bottom of the slope. Okay, so the rotational kinetic energy, and you're given this equation, is given by a half I omega squared. Now we know I, we're given that. We're not given omega, but we are given v. So we know that for a rolling object, if it's moving at a speed v, then a point on its rim will also be moving at a speed v. And that means that the angular velocity for a rolling object is just the speed that it's moving at divided by the radius. So we do know the radius and we do know the linear velocity, and so we can work out what the angular velocity is. It's just v over r, that's 0.250 over 0.058, which is equal to, just need my calculator, 0.250 over, and it was 0.058, gives us 4.31 radians per second. And so EK rotational is given by a half times 0.140, which was the rotational inertia, times 4.31 squared, which gives us a final answer of 4.31 squared gives us 1.3. Oops. 1.3 joules, and it should be to two significant figures because the radius here was only given to two significant figures. Okay. The hollow cylinder starts from rest and has an angular acceleration of 1.72 radians per second squared. Calculate the time taken to complete the first full rotation. So a full rotation, that's 2 pi, that's theta is 2 pi. So this is an angular acceleration, that's alpha. This is a rotational kinematics problem, so we're going to need to use the kinematic equations, and to do that we need to know three things so we can figure out the fourth. It starts from rest, so we know that omega I is 0, and we want to find the time. Okay, so we want to find the equation that involves those four quantities, and that is theta is equal to omega I t plus half alpha t squared, which will be equal to, this is 0. In fact, let's rearrange it for t first. Let's first just cancel that because omega I is 0. And then we can rearrange this for t. So t is going to be equal to 2 theta over alpha square root, which is equal to, so t is equal to the square root of 2 times 2 pi over alpha, which is 1.72, which is 4 times pi divided by 1.72, and then square rooted. It's 2.70. seconds. Okay, and these equations, so once you know which four quantities you're trying to work out, all of the kinematic equations are given on your formula sheet, so you just need to figure out which one involves those four quantities. The solid and hollow cylinders are both released at the same time from the top of the slope. Explain why the solid cylinder reaches the bottom of the slope first. So the key difference is that they have different rotational inertia. So the solid cylinder has less rotational inertia. As its mass is concentrated closer to the middle, closer to its axis. This means that it gains less rotational kinetic energy than the hollow one, as EK rotational is equal to a half I omega squared. Both start with the same amount of gravitational potential energy, and EGP is equal to EK translational plus EK rotational So as the solid cylinder gains less rotational kinetic energy, it will gain more translational kinetic energy. Thus, moving faster down the slope. Okay, so that's the end of that exam question. So this part D here is probably an excellence question, but basically you need to explain that the solid cylinder has less rotational inertia, therefore it has less rotational kinetic energy, because they both have the same amount of potential energy to begin with, and because the energy conservation equation looks like this, the solid cylinder will therefore gain more translational kinetic energy.